Welcome to the third tutorial for Procedural Studio. Today we're going to look at different 2D functions to create more interesting input shapes for our eroded terrain. In the first two tutorials we created a basic shape, function 2D in the shape of a pyramid, converted it to an image, and then applied erosion to that image to create the shape of an eroded mountain. Then in the second tutorial we created a simple texture for that terrain using colorize with gradient nodes based on the flow map output of our erosion node, and then use a textured terrain node to apply the texture to the terrain. Now in this third tutorial we're going to be looking at this first part, the input shape, and I'm going to disconnect the output of the basic shape function from the rest of our graphs so that the calculation time is reduced when I make changes to the input function. Now if I execute it, it will just work with the default input function, which is just flat, so our terrain output will for now just be a simple flat plane. So to create a more interesting function, the first node that I'm going to add is I'm going to add a random function grid node, funcgrid 2D random, and connect our function to the input of that node, which has many input parameters, but we can already see what it does basically is repeat the input shape on a grid. See it better if I increase the grid size a little bit, for example to 5. We can see that the input pyramid, the function that's connected here, is repeated 5 times in X and Y, and it's also randomized in its rotation, translation, and scaling. I can change the minimum maximum rotation values, and I can also change the minimum and maximum translation values to make it a little bit more random. Just leave it like this. And then if I execute, I can look at the result here in the main output window. So this is just several pyramids on a grid. Second thing we're going to do is we're going to add these two shapes that we have together, and we're going to use a add functions 2D node. I'm going to drag that here and connect our two functions to add our small pyramids to the main pyramid, which looks like this. We have a little bit more interesting shape than the original pyramid already. Now I'm going to add some more things. First thing we're going to add is some noise. If I scroll all the way down and I choose the Voronoi 2D function, this is Voronoi noise, which looks like this, with straight ridges. You can change the number of points. I'm going to leave that at 80, for example. And the second type of noise that we can use is so-called Perlin noise. I'm going to use this Perlin 2D function. This is a smoother, more wavy kind of noise. Now, because this is very high, I'm going to reduce the maximum value a little bit, and also decrease the minimum value a little bit to -0.2. That gives us some negative values, but this doesn't matter. We can work with some negative values as well. So as a next step, with these two noise functions, I'm going to add these together, also using the add functions 2D. Connect these to the inputs. By the way, these types of inputs here are so-called multi-inputs. They're used for functions that accept any number of input parameters. I can add new input ports by clicking on the little plus sign, and I can also remove input ports with the minus. If I connect to this last port, it will automatically add a new port. I'll remove these now. and execute. Now this is our Voronoi noise or Perlin noise, and this is the sum of both added together, which is already a little bit more interesting shape. So we have this pyramid with the small pyramids added to it, and we have the sum of two different types of noise. And now to blend those together, I am going to use a maximum function, which will always choose the maximum output value of its input functions as the output. So this is the pyramid with the added small pyramids. This is our noise function, and this is the maximum value of both. This gives us more interesting input shape for our heightmap terrain. I'm going to connect it to the input of the rest of the graph, calculate. Now look at the result. It's very eroded, obviously. It looks more interesting than the original now, with more smaller mountains on the side. So by now our graph has become pretty complex, and in the next tutorial we're going to look at how to group that into smaller subgraphs that are reusable. Thank you for watching.